All right, hello, Stat 113. So we're going to finish off this note packet in this video by talking about what a confidence interval for the difference in means looks like. And so we might be interested in this if we want to know, okay, well, how different were the average scores of male professors and female professors in our example? And so the first thing we want to do is we want to write down our point estimate for the difference in sample means. And so we're going way back to page 15, where we've got this slope, which we agreed was the difference between the mean for males and the mean for females. And so our point estimate is 0.1415. So is this difference males minus females or females minus males? So again, I'm jumping back to that page, and I think it's easiest to see from the predictions that we made, where we found a prediction for the score of female professors, which was also the mean, and we did the same for males. Since the males have, on average, the higher score, and this number is positive, then that must mean that this is for males minus females. Right? So again, that's because we know that males, on average, had higher scores in our sample. So since males on average had the higher score, it has to be males minus females because this number is positive. So that's kind of what I think is the trickiest part. The rest of it really is pretty similar to stuff that we've already done. So degrees of freedom, we've already written those out a number of times now, so that's still going to be 461. For a 90% confidence interval, you can use the t-distribution on StatKey to get our critical value of 1.648. And then from here, we're still using this point estimate plus or minus t star times the standard error. Standard error and point estimate, again, come from that table. I'll flip back even one more time just to emphasize that, again, estimate for the difference in means, and then its standard error is to the right. And so that means that we're going to have 0.1415 plus or minus 1.648 times 0.0508. If you calculate all that out, you'll get a lower bound of 0.05778 and an upper bound of 0.2252. Okay, and so finally, we don't just want to have this interval, we want to be able to interpret what it really means. And so our usual confidence interval interpretation started with we are 90% confident that, and then I just want to say we know that the difference in means is between these two numbers. In particular, we're estimating that the mean for males is between this 0.057 points higher and 0.2252 points higher than the mean for females. So we're 90% confident that the average course score for male professors is between, then since these numbers are positive, 0.05778 points and 0.2252 points higher than the average course score for female professors. All right, And so there's an extra note at the bottom here that just says that this is equivalent to a two-sample t-test. We just kind of went about it in a slightly different method. So what does this really tell us then? So we found in the last video for the hypothesis test that there was convincing evidence that the mean score for male professors was different than the mean score for female professors. So remember that this study, though, is still observational. So we can't really include causation of any kind unless we use some outside reasoning that has to do with something else besides this analysis. This analysis alone cannot let us infer causation. You might think about the gender bias that happens in a lot of areas in our society, and this could be a consequence of that sort of gender bias. Again, that's just based on the study. We can't say that. That's just kind of a speculation for one reason why we're seeing this difference across male professors and female professors. Okay, so that wraps it up for our simple linear regression. Where we're headed next is, well, what if we wanted to include multiple predictors into our regression model? For example, we had attractiveness and we had gender as possible predictors for course score. What if we wanted a model that included both of those? And so that's where we're headed for the very last section that we'll talk about in this class.